Now in this video, we'll briefly go through what is electromagnetic spectrum. Sometimes they call it as electromagnetic waves, and there are only 7 types. Example like gamma, your infrared, microwave, so on and so forth. Later, we're going to learn the 7. Now, a natural source of all these waves is actually from the sun reaching the earth. And I want you to remember this image because between the sun and the earth, it is vacuum. So the first thing you need to know is all these electromagnetic wave can pass through vacuum. Now the next thing we're going to go through is the properties of electromagnetic wave. So in other words, if I were to ask you the similarities between all these 7 different types of wave, you can code this also. Let's go through the first one here. Electromagnetic wave, or in short I call it EM waves, they are all transverse. Alright, and only sound is longitudinal wave. Alright, and as mentioned, they can travel through vacuum. But take note of one thing, it is wrong to say that all transverse wave can travel through vacuum because water, remember, water is a type of transverse wave also. So let's take a look at the other one. They carry, because they are wave, they will carry or they transfer energy from one place to another. And just like light, they all travel at the same speed, 3.0 times 10 to the power 8 meter per second. Do not just say that they travel at speed of light, because light is part of the EM spectrum, okay, in vacuum to be exact. But for our O level, if it's in the air and they ask you to state the speed of the EM wave in the air, you can just state 3.0 times 10 to the power 8 meter per second. And because they are all EM wave are wave, they will obey the wave equation, which is V equals to F lambda. I hope you can still remember that. And of course, another formula, F equals to 1 over T, definitely is applicable in this topic also. The next part here is when an electromagnetic wave travel from one medium to another, okay, the speed and the wavelength, the lambda, will change. And what stays constant that do not change is your frequency. It remains constant. Remember, in general wave property, we mentioned that once the wave is produced, the frequency remains the same because frequency depends on the source. So using the wave equation, V equals to F lambda, and frequency is constant. So in other words, your speed is directly proportional to the wavelength. So when one increase, the other one will increase. All right, and vice versa. So the next point is just like light that you have learned, they'll obey the laws of reflection and refraction. Okay, and next, they carry no electric charge. Okay, so in other words, they will not be affected by electric field or magnetic field. Okay, but we'll learn that more in set 4. And they're actually just electric, and electromagnetic wave are actually electric and magnetic fields oscillating 90 degrees to each other. Okay, just take note of that, no need to go into detail for that. So that's the properties of all these EM wave. Now next, another one of the important things for this chapter is knowing the names of the 7 wave and also the orders of the 7 wave. Now, a student actually taught me this. Okay, he uses this phrase to remember, and I find that it's very easy if you can just it sticks to your mind and then you can recall it easily. So let's go through the phrase here. Let's take a look at this image here. So you can think of it as your grandma. Her underwear just stays in your room, lingers in your room. So the phrase is grandma's extra, okay, start with X, not E, extra underwear lingers in my room. Just take note of the first letter of every word. So that will help you to recall is gamma ray, X-ray, ultraviolet, visible light. Because only human being we are able to see this. All other wave we can't see. Okay, then followed by your infrared, microwave, and radio wave. So that order is very important. Now, Then plus another thing to memorize. Okay, it's up to you, but I'll prefer, I mean, for me, I remember radio wave has the longest wavelength. The lambda, the wavelength is the longest. If you know that already, the rest will fall in place, because since radio wave have the longest wavelength, that means to say the other side of the spectrum, the gamma ray will have the shortest wavelength, and on the other hand, the frequency of gamma ray will be the highest, and frequency of radio wave is the shortest. In other words, this is increasing in wavelength, and this is increasing in frequency in the opposite direction. But one thing, what governs them together is V equals to F lambda. Remember, they all travel at the same speed in vacuum, 3.0 times 10 to a power of 8. All right, so the relationship between your wavelength and your frequency is inverse proportion. That's why if you have a very big wavelength for radio wave, the frequency will be obviously smaller. So when you times them together, you will get back your 3.0 times 10 to the power 8. So let's go back to the summary here and filling the blanks. All the 7 wave, they will obey wave equation V equals to F lambda, and they all travel at the same speed, and this value you need to memorize, 3 times 10 to the power 8 meter per second in vacuum. All right. Now, some of you may be wondering, do I need to memorize all the various respective wavelength and frequency? Well, the answer is no, no need to memorize, but roughly you get a sense, like from gamma ray, the wavelength is very small in terms of 10 to the power minus 12, or until radio wave, which is in terms of a few hundreds. Now, for just like in chapter 1, we mentioned that so far, O level we tested you is diameter of the atom and diameter of the hair and plus diameter of the earth. So these three are commonly asked. It's good to know the diameter in terms of the times 10 to the power how much. All right. And another thing to take note is, as mentioned, gamma ray will have the highest frequency. Highest frequency means higher energy. So do take note of that. Now, the next thing we need to go through is the application and usage for all the respective waves. You have to memorize the application at least about 2 or 3, or you can quote what's the wave that is used for that application. Let's start with the first one, which is your gamma. Now, the irony is gamma ray, if you are exposed to it, it might cause mutation of the cell, spoiling the DNA, which might lead to cancer. But on the other hand, if you can actually focus and target the gamma ray to a tumor or cancer cell, they can actually destroy it. So gamma ray is used for radiotherapy for cancer treatment. Right now, another usage is for sterilization of medical equipments. Now, do not just say clean the medical equipment, so use the word sterilization. All right. Next, we have X-ray. We are familiar with taking X-ray images of broken bones. So how it does is the X-ray can pass through the body tissue and it hits the film at the back. That's why it appears as black color, but it will be blocked by the bones. So it will appear as white because it doesn't fall on the film. So take note is to take X-ray imaging to detect broken bones. Don't say take photo of broken bones, all right? The next application will be for in the airport for airport security, where we check our luggages. Now the next one, I put it underneath both here. So for metal welding, for pipes, etc., you can actually use gamma or X-ray to check for cracks. All right. Next, we have ultraviolet. Now, over here, it is good to put there artificial sun tanning in sunbed. Okay, because when we talk about application, that's what we want. Okay, but normal times, normal days, we actually do not like to be under the sun because it can cause pigmentation or even lead to skin cancer or freckles or whatever. So it's good to put there is sunbed because you really want to get the suntan. So artificial sun tanning. And UV, of course, got UV A, B, and C, but there's no need for you to know the details. But the one that is used for sterilization is mainly UVC that is artificially made. All right. So likewise, as just like your gamma, both you can code sterilization of medical equipments for their application. Now, the next one is your visible light, and we know that the visible light is made of 7 colors, and we can only see this visible spectrum. All other wave like your ultraviolet, microwave, we can't see them. And how do you know which side is the red and which side is the violet or the blue? And I mean, the hint to you that you always remember is infrared. So obviously this side here, nearer to the infrared, is the red color. And the other end, another hint is ultraviolet. So your violet or your blue will be on this side. And how do you know which red or violet has longer wavelength? As mentioned just now we said that radio wave has the longest wavelength and the wavelength decreases slowly. So obviously the red color will have higher wavelength than the violet or blue. Okay, likewise for the frequency you should know. So next, let's go back to the application for visible light. Of course, your fiber broadband, your broadband at home. All right, the fiber is very thin, just like a hair thickness. They carries the information in terms of zeros and ones. And another thing, of course, allow us to see, allows photosynthesis to take place in plants. Next, we have your infrared. So all of you have this at home, remote control, okay, for television or that, or your air conditioner. So the power is very low, so you can't really feel the heat. All right, so take note, do not just say control the TVs. The teacher might ask, is are you referring to the button? It's actually the remote controller for TV or the aircon. Next, your infrared thermometer to measure your temperature. And the next one here, which is very commonly asked in O level, is the intruder alarm. So if the intruder enters and it blocks the infrared ray, which is invisible, all right, it will sound the alarm. So take note of that. Now the next one, microwave, commonly asked also. Now let's talk about the most common use, which is your microwave oven that is used to heat up food. Do not say cook food, okay? It's to heat up food. So basically the microwave will excite the water molecules, you rotate and vibrate very vigorously and rub against each other. That's why produce the heat and that heats up the food. So that's one application. Now the next one is, take note of this, is your satellite communication. So whenever you see the word satellite for our level, we just state that it's using microwave. And the reason why microwave is chosen instead of radio wave for satellite is they can pass through clouds and rain. So you can send the signal to the satellite in the outer space, it will send to another satellite in the outer space, then back to another satellite dish in another continent. So, but the only bad thing is the alignment has to be precise. All right, so satellite communication, microwave. Another one which we can't live without is your handphone, your mobile communication. So all this is using microwave, take note of that. And the last one will be your radio wave. And radio wave is used for local broadcast of your television communication or your radio communication, like your Class 95, your Power 98, so on and so forth. So that's for local broadcast because radio wave has long wavelength. They can cover a wide area. So these are the application. And just in case some students always like to ask, how about the Bluetooth that you use for your wireless earbud or even your Wi-Fi at home? So they operate around, sorry, so they basically operate around this frequency, the lower spectrum frequency of the microwave. And they are actually quite safe because the power that all these device use is actually very low. So it doesn't cause any kind of harmful heating effect, like it won't fry your brain or whatever. So don't worry about that. So that's where the wave that is used. All right. So that's all for application. Now, the last section that I want to go through is about the ionizing effect. So first of all, let's go through what is ionizing effect. It's basically the process where electrons is given enough energy to break away from the atom. That's called ionization. And this result in the charged particles like a positive ions and electrons. And this actually will create chaos in the cell or the body. Now, another thing I want you to take note is out of the 7 wave, only these 3 will have ionizing effect. And of course, this will be the strongest and ultraviolet is the weakest. That's why ultraviolet can only cause skin cancer, the mutation of the cell, but it only leads to skin cancer because it cannot penetrate through the skin. You only affect the cell on the skin level. All right. So what's the harmful effect? You can always state these 3. It can damage the cell, the DNA. It can cause mutation of the cell, which might lead to cancer, or basically it can just cause the death of the cell. You kill the cell. So always you can quote this causing mutation of the cell, which might lead to cancer or that. But take note, as mentioned just now, if it's just skin cancer, that is your UV. Ultraviolet can only cause skin cancer, not other cancer in other parts of the body. And also in general, all the 7 wave, they will have some form of heating effect. Of course, the more obvious one will be your infrared. Even your visible light can cause some heating effect. But so another thing to take note is, okay, photons. This one is not really in our syllabus, so not to worry. And the last point here, as mentioned, the higher the frequency, the higher the amount of energy. So that's your gamma basically. So I hope after this video, you will have a clear picture and overview of the electromagnetic spectrum. All right, thank you.